that, I welcome Dr. Wenjing Wang to TaiyangNews. Dr. Wang, you may please take over the floor.
Hello?
Yes, we can hear you.
Yeah. So,
you can please share your presentation.
okay. So can you see my presentation?
Not yet.
So right now it's okay?
Yeah, just get into the presentation mode, please.
Okay.
Yeah.
Okay.
Good.
So, hello, everybody. It's very glad to show my recent work in Huasun. Here is the title of my presentation. It's the progress of HJT in Huasun. So we separated three parts for my talk. The first is a cell efficiency progress. We can see there's a few steps to increase it is the Huasun HJT technology roadmap. Right now, we already arrived to the HJT 3.0. So it's a mean in double side is we used microcrystalline thin film as a passivation layer. So the efficiency arrived 25.5%. But recently, we further improved the efficiency. We can call the HJT 3+. It can further increase the efficiency to up to 26%. So here's the world record of HJT solar cell in the lab. Right now, still the efficiency is still 26.81%. This data get by LONGi in 2022. But in this 1.5 years, this record efficiency cannot further increase. But in the mass production, the efficiency keep increase. For the originally for double-side macrocrystalline silicon heterojunction solar cell, the average efficiency arrived to 25.5%. So after that, we improve some few steps to further increase efficiency. This including the we increase the lifetime of silicon wafer, and we use a lower rate of PECVD, and we use a narrow ITO edge. We use the steel mesh screen printing. We use silver paste and high density finger. This efficiency for mass production can arrive to 26.2%. But in the mass production line, we have to balance the efficiency and the cost. So maybe we use a little bit lower lifetime silicon wafer. We use a faster PECVD process. We use a double silver copper paste. All of these reduced cost step will decrease the efficiency. So for the mass production, the average efficiency arrived 25.7%. But maybe we can further increase efficiency. That we can use the silicon backside polish. We can use RPD to make a very good TCO. We think we already do as experiment. The efficiency can further increase 26.5%. But this technology cannot right now still not in the mass production. So here's the HJT1 is the average efficiency is 24.3%. and HJT2 is 25%. That means double. In the front side is microcrystalline silicon thin film, but back side is still amorphous. So here's a double-sided microcrystalline silicon. The final result is 26.15%. Here's originally is 25.4 to 5%, and after the further improvement, the efficiency arrived to the 26 to 26.2% in golden line, but in for the mass production, it's 25.7 to 8% for mass production. So the second, we will talk about module power progress. For the module, according to the high efficiency solar cell, the module power can arrive 725 watt for mass production. The record of the power of module for HJT G12 172 half piece, the recorded power in Huasun is 750, but in the Tongwei they arrived a higher power to 755 watt. So we find that for the high efficiency solar cell, the CTM a little bit lower, but the power of the module still can arrive 725 watt. So we talk about the main improvement for the solar cell, how to increase efficiency. The main technology is we use a new kind of screen printing, which is steel mesh screen printing. Originally, we use a traditionally woven wire mesh. The peak of the finger a little bit higher or lower, and the width of the finger narrower and wider. So it's not uniform. So the contact is not so good. But we use a steel mesh. The peak of the finger can keep in the same level, and the width also keep the same width. So the efficiency keep increase. Use this kind of technology. So we talk about next. We will talk about the zero-busbar technology. So these a few years, people keep increase the number of the busbar from the 6 busbar to 9 to 17 busbar, and even larger than 17 busbar, 16 busbar. Right now, many company try to introduce the zero-busbar. I mean, no busbar. The advantage of increasing busbar is it can increase module power, reduce the package loss, and reduce the manufacture cost. For the advantage of a zero-busbar, certainly they can reduce the consumption of a server past, and they can compatible with the thinner silicon wafer, and also it improve the module reliability. So right now in China, there's a few kind of technology road for this kind of zero-busbar. The first type is SWTC, is mainly developed by the Meyer Burger. And the second one is IFC, is there's a few company in China develop this technology, the Xiaoniu and Maxwell. And the third one is dispensing technology developed by the Autoway lead. And the next is waiting dispensing. developed by the Maxwell. For the key point for the encapsulate material for the SWTC is a composite film plus encapsulate. And for the IFC, it's a use of skin film encapsulation. For the dispensing, use a PVB or EVA. Use a skin film plus EVA. Use a the weighting and the plus type. We use the standard EVA. The alloying for first three technology, they use lamination. During the lamination, they make alloying. But for the last one, they use make alloying in thread during the wedding. So it's quite different. So the advantage of the Huasun zero-BB technology, the first is a single use a single printing technology. It can reduce the paste equipment technology and the cost, and improvement the efficiency, the power, and the reliability. For this technology, the efficiency of the module can increase a little bit, and yeah. And for this, we can get a higher reliability, so we test the DH even to the 3,000 hours. It's passed, and also use a TC 100 to 600. It's compatible with MBB. And for the higher, for the reducing the occasion of the hotspot, because we have a pre-weathering, so it's a hotspot, the temperature is low. So distribution of electric current evenly lower than surface of the cell. So the next is higher we use a different the UV test of zero-busbar module is okay, is passed. And the dynamic and the static mechanical load testing of our zero-busbar module is passed. So the reliability is no any problem. The third advantage of our technology is the use the metal shattering area on the front and back side of zero-busbar is less. The light received area is higher, is larger, so the efficiency of the module is high. At the same is the same in the back side. The shattering of the the wire is low, so the double bifaciality is high, up to the 90%. So if increase the bifacial, the generation, the power, the generation energy is high. So the summary of my talk, the first, recently some new technology are introduced into the mass production, which increased the HJT average efficiency up to the 26%. The second is, moreover, the power of the module G12132 in mass production has arrived 620 watts. The zero-busbar technology are introduced into mass production to further decrease the cost of HJT. Combined with the silver copper paste, the copper consumption can be decreased to the 7 milligram per watt. Thank you very much.
Thank you, Dr. Wang, for that very comprehensive overview of the cost reduction efforts at Huasun. I shall reserve my questions for the panel later today, but it would be great if you can please join the chat and see if there are any questions from the audience that you would like to answer. Thank you so much. I